Hi, welcome back. Operating system means which can act as an interface between user and computer hardware, right? So basically we have various types of operating systems are there. One is Windows operating system, Mac operating system existed, Ubuntu operating system existed. If you look into a kind of mobile related kind of operating system, that will be Android operating system. Like that, we will have various kind of operating systems are there. Right? Earlier days, at the initial stage of development of the operating system, we have an architecture called Van Neumann architecture. Means how our operating system is working and interact with the computer hardware, right? So general, if I say there will be an user and there will be a kind of hardware, something like this, and between user and the hardware there will be an operating system. Can we directly interact with the operating system? No, we can't interact with directly the operating system. But if you want to interact with the operating system, in the last video I have explained how we can able to interact with the operating system directly with the help of a command prompt, with the help of a system call interface, or with the help of an application programming interface. But we cannot interact directly. So here we have a layer. That layer means user can able to interact with this layer directly. This layer can be a kind of command interpreter, that can be a shell based command interpreter or GUI based command interpreter, or system call interface, or it can be a kind of application programming interface. Now through these methods we can able to interact with the operating system. Then operating system will directly interacting with the computer hardware, and if there are any kind of processing is going to happen, that will respond back, and operating system call will return it, that will be send it to the end user. This is where your response is going to get processed. Okay, here user means again saying it can be a normal user, or it can be a kind of any kind of high level language, like it might be any kind of C, Java, any kind of programming languages. Okay, so if you look into the in-depth about the hardware of the device, in general, this hardware of the system, don't worry, it's a kind of a circle I am trying to draw. I am not good at this diagrammatic part. So hardware contains, one is memory area, and we have the main heart of the system, CPU, central processing unit, where it can take certain kind of input devices and it will produce, and it connected to the output devices, right? And memory and CPU are connected. And if you look into the CPU internally contains, one is control unit and another one will be arithmetic logical unit, right? So generally, if you look into here, the hardware contains majorly three building blocks, guys. One will be the I can say central processing unit, and another one will be memory area, and another one will be various kind of peripheral devices. Those can be connected in to give certain input to the system or to produce certain output to the system, right? If you look into here, central processing unit, clearly it contains two parts again. One is control unit which is generally responsible for to handle various kind of timing and control signals, guys. Right? So in other words, if I would like to say, it is going to control various kind of flow of instructions. It will direct all kind of peripheral devices how to work. Like it can monitor how input and output devices are going to work, all those things. That will be managed by control unit. In simple words, control unit is going to control all kind of things which is going to be happen inside the system. Okay, coming to the other part of the CPU, that will be arithmetic logical unit, which is meant for to perform various kind of calculations. Those calculations can be again arithmetic operations or any kind of logical operations. Right? Yes, this is what all about CPU. And peripheral devices means these can be any kind of input devices, something like it can be a kind of keyboard, monitor can be like a kind of touch screen, right? Touch screen can be a kind of input device, and some kind of output peripheral devices can be again a monitor which will view the results, and some kind of speakers where they can produce sound, etc. These will be a part of your hardware. And coming to the important aspect where you may get many gate questions related to it will be memory. This is an important area in this video. So generally if I want to perform certain kind of a requirement, that requirement satisfaction done by application developer by writing various kind of instructions like instruction 1, instruction 2 and so on, n number of instructions the developer is going to write, right? If you want to execute this requirement, it has to be reside in the main memory of the system, or I can call it as a rewritable memory, right? If something wants to execute in the system, that has to be available in the RAM, random access memory. If we say specifically, that will be a DRAM. DRAM is the location where all your instructions are going to be executed, right? So if I say now this will act as a program, all the collection of instructions will act as a program. If these instructions are present inside DRAM, then I can call it as a process. The instructions which are under execution, that will be called as a process. Which are under execution means they should reside inside the DRAM. This is one kind of memory, right? But in general, in the reality, we are having huge number of programs are there, right? It's not only about the programs. We are going to have various kind of like storage required, something like I want to store videos, I want to store MP3 songs, something like that. All this having huge amount of storage requirement is there, right? Which means that if you generally look into the DRAM or a RAM, the problem with these things will be, in general, these having less storage capacity. Am I right or not, right? So nowadays generally we have 8 GB of RAM. If you look into something, 8 GB of RAM or 16 GB RAM, like that we may observe general most frequent things, right? So which means that which is a very less storage capacity. Less storage capacity means if I want to store more data, I cannot able to store in the DRAM or the RAM directly. And one more thing is, this RAM is a kind of volatile memory. Volatile means, in general, when your system is power off, all the data what is reside inside the RAM get be erased. That is what we call it as volatility. Volatility means the data which you have placed inside the RAM or DRAM will be erased completely once it turned off, right? So these are the two drawbacks of a RAM. To overcome these drawbacks, they come up with a solution. That solution will be various kind of secondary storage devices. These secondary storages will avoid these drawbacks, means it can store, it can have vast storage capacity, and these are non-volatile, right? Means when the system power failure also, our data won't be lost. This data is going to be stored permanently, right? Secondary storage devices, which I can call it as external devices. External devices which can store the data, right? So that is the reason we are trying to go for various kind of external devices, right? So generally we have two types of memories. One is primary memory, another one will be secondary memory, guys. Secondary memory, right? So in primary memory, the things something like RAM and cache, registers and ROM will becomes under primary memory. Okay, coming to the secondary memory, the examples will be something like magnetic disk, or if you take any kind of pen drives which are detachable, guys, all those will becomes under secondary memories. Something like tapes, magnetic tapes, etc., right? These secondary memories can able to store a huge storage. Okay, fine. So generally these RAMs, they come up with these RAMs, it is because of with various kind of factors. For example, let me say the factors can be, one is with respect to size, one is with respect to volatility, right, and something with respect to speed, right? If I am storing something inside the RAM, I can able to access more fast compared to storing inside the secondary memory, something like that. Based on various kind of factors, we are going to go with the various kind of memories. If you look into the exact hierarchy of these memories, let's see the hierarchy of the memory. Observe, guys, here clearly registers is the top level and magnetic disk are the lowest level, right? As I mentioned already, with various factors they made this hierarchy. We can call this as memory hierarchy. Registers are at the top level and magnetic disks are at the least level. If you look into the size factor, registers having low size, less size, and magnetic tapes are at the vast capacity. That is, this arrow indicates, right? As we are moving towards downwards from top level to lower level, the size is going to be increased. But when we are moving from lower level to top level, speed of accessing the memory will be increased, and cost of the device is going to be increased, right? So generally in the real world, when you go with buying some kind of magnetic tape, which will be less cost, right? But when you try to go with certain kind of registers, cache memory, accessing them will be more cost. Okay, fine. So this represents the hierarchy of the memory, right? Yes. So here you have to know one important point here: solid state disk. After the main memory, solid state disk is there, magnetic disk, optical disk, and magnetic tapes, right? Here the important one is, in some kind of examinations I have observed one question is related to SSD. What is the full form of SSD? Is it a secondary storage device or is it a solid state drive? Right? Options will be secondary storage device, and another option will be solid state drive. Which is the correct answer? The correct answer will be solid state drive, but not secondary storage device. This is important, guys. In one of the examination I have observed this one. Solid state drive is the abbreviation for SSD. Okay, fine. And one more important one is when you turn off your system, and again you are going to turn it on, right? You are going to turn it on. Actually, when it turns on, your operating system has to load. But before operating system, there will be a program called bootstrap program. This is the first program that is going to be run when your system is turned on, or I can call it as BIOS. This is the first one that will be loaded when your system is going to be turned on, right? Where it will be resided means bootstrap program will be resided inside the RAM, right? If we are going to reside it in the RAM memory is going to be lost or not? Yes, that's the reason they made it stored in the RAM. Hope you understood this video, guys, clearly. Thank you.